Hi, welcome to my video. Now, in this video, we are going to look an overview of the units that we are actually going to cover under Engineering Mathematics 2. So hopefully, Engineering Mathematics 2, it won't be challenging as Engineering Mathematics 1, which is what we covered last year. So remember, I'm also a student of chemical engineering. So what I do on these videos is I'm just passing the information that I believe I understand or the information that I believe I've tried to master by myself. So feel free to leave the comment under the comment section below if maybe you have some questions, or maybe if you want us to interact, or if maybe you have some suggestions so that we can see what we do about that. So in this video, I'm not going to dwell on the content as yet. In the next video, that's where I'm going to do the content. But in this video, we're just gonna have an overview of the units that we really need to study, or the units that we are actually going to focus on to under Engineering Mathematics 2. So let us start with the year plan, okay? We have the year plan that we're actually going to use. So now, Engineering Mathematics 2B, we have a provisional year plan for semester number 1. Hopefully everything, it hasn't been changed because this material is a material that was used last year. So I think nothing has changed, okay? The dates most probably they could not be accurate for this year. So we're not gonna focus on the dates, rather we're gonna focus on the topics that we are actually going to talk about. But you can also try to refer to the weeks as we talk about the topics, okay? But the dates, probably they might change as well. So now let's have a look at semester number 1. We're gonna have a look at semester number 1 and the number of units that we actually need to cover for the whole module, okay? Which is Engineering Mathematics 2. Now, for week number 1, it seems like the first topics that we need to focus on to, I'm not going to talk about the welcome and orientation. We know that it's a thing that's going to happen. It has already happened in our class. We still need to do a revision on functions integration, partial fractions, and integration by parts. And that's what we did under Engineering Mathematics 1. We spoke about the partial fractions and we also did the integration by parts. So before we can start before we can start all of the units, this is where we need to start. Remind ourselves how to solve integration by parts. Remind ourselves how to solve the partial fractions. Okay, I might as well. In fact, that's what I'm going to start with when I do a video where I'll be taking the content. I'm going to start with partial fractions and integration by parts. And for study unit number 1 for EMA 206B, we're going to look at first order differential equations. Okay. You need to understand that this is calculus, and semester number 1, it's mostly highly composed of calculus. Semester 2 last year, under Engineering Mathematics 1, we did introduction to calculus. So right now, we're not going to do introduction to calculus, but we're going to do introduction to the units that are found in this Engineering Mathematics 2. So we're going to learn what are differential equations. I think and believe that we all understand what are differential equations. For an example, we have different types of equations, right? We can have the algebraic equations, we can have the differential equations, but under the algebraic equations, we know that we can have 2 solutions depending whether the algebraic equations, it is quadratic or not. And we know that under the algebraic equations, we can also get one solution. For example, when we have a linear function, we can get only one solution. But when we talk about the differential equations, this is where we're gonna have to look at many different solutions. And these solutions can be represented as functions. I mean, like you will be solving your equation and that equation, its solution is another function. That's how it works under differential equations, okay? So probably under study unit number 1, we're gonna do introduction to DEs. We call them the differential equations. We're gonna learn what are differential equations. That's the first thing that I'm gonna start with under study unit number 1, okay? And also we're gonna do the direct integration with applications, okay? We're gonna do the direct integration. You know that when you integrate, we use that symbol that looks like S, right? So that's the symbol that we use when you integrate. Do not confuse differentiation and integration. Remember, those are vice versa. So that means what you integrate, you should be able to differentiate. What you differentiate, you should be able to integrate as well. So that means that's what we're going to start with. We'll start with introduction to DEs and direct integration with applications. And therefore, while we are still under unit number 1, which is first order differential equations, we're going to have to look at separable differential equations. Okay, those are things that we're going to look onto. Okay, separable differential equations, and then we're going to look at reducible to separable. Okay, we're going to look at reducible to separable, which are homogeneous equations. We're still going to have to do that. You see that under the Bernoulli. Still going to talk about the Bernoulli. What's happening now on my PC? I just opened up my PC. And therefore, while we're still under first order differential equations, we're going to look at the applications such as exponential growth or decay, and other applications that we're going to look, which is the applications of what we have covered. We're going to do Newton's law of cooling. So look, here's the thing. Calculus has application in real world, right? But at this point in time, we're going to learn calculus as mathematics, and then we're going to apply that mathematics into different situations. For example, let's talk about the exponential growth. When you talk about exponential growth, you can talk about finances, right? We can talk about the finances. We can talk about the death mortality rate, natality rate. We can talk about all of those things, but you need to understand that sometimes mathematical concepts that we use to solve those problems, they actually employ calculus. So now the calculus that we're going to talk about, it's this one that I have just mentioned above, which is first order differential equations. And also under unit number 1, we're going to talk about the linear first order, which are called the ODs, okay? First order ODs. So first order ODs are simply referring to order differential equations, okay? We're going to look at that. While we're still under unit number 1, you can see, guys, unit number 1 has a lot by itself. We only have 3 units that we're going to do before the recess, okay? Before the recess for semester number 1, we're going to have to focus only on 3 units. And therefore, while we're still under first unit, which is unit number 1, first order differential equations, what are we going to look at? We're going to look at reducible to linear, where now we're going to talk about Bernoulli. I love Bernoulli. I've encountered Bernoulli several times. We're going to do Bernoulli, which is reducible to linear, which is also the first order differential equations. And therefore, again, we're going to dwell onto the applications of linear equations, mixing problems, such as electrical circuits, etc. Okay, so we're going to do applications of linear equations, which most definitely involves Bernoulli. We're going to have mixing problems. We're going to have electrical circuits. This is just application, and you need to understand that. And there are many different types of applications that we can actually talk about under the Bernoulli. You'll see that as time goes by. And then I'm just going to pass this part, which says no class. And then about week number 7, still under unit number 1, we're going to do the numerical solutions, error analysis, and the applications of unit number 1. So unit number 1 by itself, you can see that it has a lot. It really has a lot, and we'll take it step by step, and we really don't have to panic. It's mathematics, I understand, and it's hard to tackle mathematics, but we'll try by all means to go through this module, and we pass it, and we move to the next year, which will be next year. Okay, that's simply or roughly unit number 1, and you can see that these units, they have about 6 units. I have about 6 weeks, just only unit number 1. Imagine, that's a lot to cover right there. Now let's have a look at study unit number 2. Study unit number 2, it's now called the high order DEs. We know that DEs simply means differential equations. So now we creating the standard. So we're gonna do the high order DEs, methods of underdetermined coefficients. Okay, so the first subunit under unit number 2, the theory. We're gonna talk about the theory, method of undetermined coefficients, homogeneous. Okay, this is also calculus. But now we are talking about the high-ordered differential equations. We started with first-ordered differential equation. Now we're going to high-order differential equations. Okay, so the first subunit is theory. We're going to talk about the method of undetermined coefficients, homogeneous, such as homogeneous, and therefore we're gonna do the non-homogeneous, right? We're gonna do the homogeneous. We're gonna have to do the non-homogeneous, which are referred to standard equations. And therefore, study unit number 2, which is the very same unit, we're gonna do non-homogeneous and now special ones. Now we're gonna focus on special ones. Probably this will be during the holidays, I think, but we'll see about that. And therefore, while we understudy unit number 2, now we're gonna do the application, the spring mesh system, the spring mesh system. So in this case, we're gonna do the LCR circuits, other where models is given. Remember, this is just application, and when it gets to application, we need to understand that we're gonna have to apply the basics that we have learned so far in real-world problems now. Okay, and therefore that will be the end of study unit number 2. After recess, for sure, study unit number 1, probably it will start after recess. I don't know, maybe, but we'll see about that. And then study unit number 3, we're going to talk about the high order differential equations. Now we're going to talk about the Laplace transformation. I remember I had a friend, he once told me about these things. I think under some modules, not only engineering mathematics, as chemical engineer student, still going to learn about the Laplace transforms. I think this other module, but I'm not, it's fine, we'll see. So Laplace transformations, this is what we're going to learn. Okay, this is calculus, high order differential equations. We're going to start with introduction, Laplace transformers, yes, from first principles and from tables. First principles that you know, when you differentiate, the rate of change, the very same first principle, but now we're going to use the Laplace transformations, but you'll see how it works. Now things are getting more complex, they are getting more, little bit challenging, but we'll just dedicate our time to all of these things. And therefore, we're still gonna have to do the inverse Laplace transformation using tables and complete the square. Okay, complete the square. I know you know completing the square, right? When you are given the, if maybe you want to solve the variables, if you want to solve the intercepts, I can say the roots of quadratic function that do not have, that is not easy to solve. We can also we can also complete the square to solve that, but it's fine. We'll do this under Laplace transformation. We'll see that. Did my research, I did my overview, in all of these things are a little bit challenging, so we're gonna need more time to do these things. And therefore, while we are still under unit number 3, we're gonna have to revise partial fractions. Oh my God, the partial fractions had it come again. That's why it's very important for you to understand engineering mathematics 1, engineering mathematics 1, because partial fractions are again gonna be there under high order differential equations, the Laplace transformation for sure. You're gonna forget all about these things, but under study unit number 3, we're gonna have to revise that once more again because we studied with it under study unit number 1. Okay, all right. And therefore, we're gonna do the inverse Laplace transformation after partial fractions. And the part that we're gonna do under Laplace transformation, unit step, head side and impulse, Dirac delta functions, definitions and graphs. And also we're going to do the Laplace transformation, derivation and rules 19 to 22. But obvious, we'll look at these things while we are solving them. So I hope the journey will be nice. I'm not only going to teach this module, I'm also going to teach other modules. Remember, everything, it becomes hard if you don't put yourself in it. So my message to you is aim beyond the stars so that when you fall, at least you fall amongst the stars. And I would like to say thank you for giving me your time listening to this video until we meet again next time. Thank you.